Okay, here we just want to talk about different types of mathematical statements. So as we saw before, there's expressions. So the biggest thing about something that's called an expression is it generally doesn't have an equal sign. So it might just have some terms like that, some terms. And terms I like to think of as little islands that are separated by plus or minus signs that are not inside a bracket. So here is a minus sign not in a bracket and a plus sign not in a bracket. This plus sign here is in a bracket. So what we have here is one term, two term, three terms. And the only thing that we can really do with expressions is simplify them, so write an equivalent expression. So for example, we know that this multiplication here distributes over the entire bracket, over the addition here. So I can write the 3x squared, and then I can go 2 times x squared is 2x squared, and 2 times 2x is 4x, and then I can write the last term there. So I've changed my number of terms because there's now 1, 2, 3 plus or minus signs that aren't in brackets, so that gives me these 4 terms, and 2 of them happen to be like terms, so I can go ahead and add them together, and now the whole thing is simplified. So that's the kind of thing that you can do with an expression, is you can simplify it, and basically you use BEDMAS or forward BEDMAS, or kind of your laws that allow you to distribute multiplication over addition and things like that. Okay, the other kind of things that we have in math is we have equations, and there's basically probably 3 main categories for equations. One is identities. These are things that are always or almost always true. So here's an example of something that is always true. So it doesn't matter what value you pick for x and y, 3x plus y is the same as 3x's plus 3y's. And this will work no matter what x or y we substitute in there. So that's always true. Here's an identity that's usually true. Say 1 over x will be equal to 2 over 2x. Because on the right-hand side here, we have a factor of 2 in the numerator and 2 in the denominator. So this fraction can be reduced by canceling these 2's, and 2 over 2x is the same as 1 over x. But this would not be true if x were 0. Okay, so this is almost always true except when x is equal to 0. So those are identities. And then we have 2 other categories of equations. One we can solve. So say 3x equals 12. And these we solve by using reverse BEDMAS. So what we want to do is undo operations. So just like however we get dressed, pants and then shoes, when we want to get undressed, we take our shoes off and then our pants. So this is the manner of doing things if we want to reverse. Like, I don't like the fact that someone's multiplied my x by 3 because it makes it hard to tell what it is. So I'd like to reverse that multiplication. So the opposite of multiplication is division. So I just go ahead, keep my equation balanced by doing the same thing to both sides. And I find out that this equation, 3x equals 12, is solvable. It has one solution. The only time that 3x will equal 12 is if x is 4. So there's one very specific value that we can substitute in there that will make this a true statement, and that is 4. So we can check that by saying 3 times 4 equals 12, 12 equals 12, totally true. So there's solvable equations, and then there's equations that are not solvable. For example, we could ask, what value has a square root that's equal to minus 5? Now, if you know how to solve an equation that has a square root in it, then you might think that there's a solution to this, because we're like, oh, I don't want the square root. I want to unsquare root the x, which means squaring it. So I'm going to square this, and I'm going to square that. And this, when I square the square root, it goes away. And when I square negative 5, I get 25. So now it looks like we have one solution. But if we take this solution and put it back into the original expression, which was the square root of x equals minus 5, we find out the square root of 25 equals minus 5, but the square root of 25 is 5. Because when we have this expression right here, we're always referring to the positive root. So this means that there is no solution. This statement right here is not solvable, because by definition, when we write the square root of x, we're referring to the positive square root, so it couldn't be a negative value. So those are the different kinds of mathematical statements that we can have.